Okay, so now I want you to drive us through optimal measurement structure. So there is a lemma saying that a measurement mx of x is optimal for discrimination if and only if y is equal to the sum of x probability of x of mx rho x is Hermitian and satisfies. So if y is Hermitian and satisfies y equal to probability of x px for all x. So literally it's a definition of the dual. And so basically what you want to say is like to use complementary slackness because the condition says like if you multiply like the perfect solution of the primal by the solution of the dual, it should be equal to 0. And so we just have to do this, like to take two matrices, one representing M being like measurement strategy for the primal, and Z being like blah 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 for the dual. And yeah, that's like representing like the dual measurement of the dual. So if we take like M and Z, like we can define M being the sum of x multiply xx with measurements, and Z is the dual. Like it's not really the measurement strategy, it's more about to be really precise it's literally so you have M is equal to sum of x and Z, which is equal to the dual xx multiplied by y minus probability of x by x. So the difference between both of them y and the ponderated states, and so we have this. And so if we calculate like mz, just like the sum over x, xx, or mx. So multiply by the sum of x, xx, xor y minus probability of x multiplied by rho x. And so it's just equal to the sum of xx, xor mx multiplied by y minus probability of x multiplied by rho x. And so we just want to having this equal to 0. So we need to have like each of the block being individually equal to 0, which means like we need to have this equal to 0, and yeah. So let's try to have this equal to 0. If we develop this, like just mx of y, which is equal to mx of probability of x multiplied by px, so rho of x. And so to have this, we can just like take the first sense, so let's try to prove that if we take, for example, our measure mx being optimal, it should respect the persistent equality, and so we try to sum over all x, like here, because it does not depend on x, we can factorize like this. And we know, like, by definition, this is equal to I by the definition of a P of M, and so we have y, which is equal to the sum of mx probability of x rho x, and so we have like the optimal solution of the dual problem, which should normally respect two conditions, like she's Hermitian and 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 yeah, she's Hermitian, and y is semi-positive, and square to this, which clarifies that Z has semi-positive blocks, and on the reciprocal side, we just have like we just need to have like trace of y, which is equal like to the trace of the sum of x mx bx for x. Like if we calculate the trace of y, we have this, and so that's exactly like the we have exactly the form of the POVM, like it's exactly the formula of the probability of success for primal, and so by optimization, the dual is always a superborn of the primal, and if we find the dual point and the primal point that give exactly the same value, it seems impossible to do better, and the 2 points are simultaneously optimal. So it's okay here, it's okay here, and we're done.